Hello students, today we are going to discuss chemistry, study of elements and their compounds, periodic classification of elements. So let's start. First of all, I would like to tell you history about the periodic table. The scientists who have contributed for periodic table are, first of all, Horace G. Deming. First he divided the elements into metal and nonmetals. After then Dobryner came, he was a German chemist. He had given his Trade's law. After the Newlands came, that was the law of octaves. After then Lothar, he had plotted a graph between the atomic mass and atomic volume. After then Mendeleev, a Russian chemist, he had given the periodic law. He said that atomic mass is the fundamental properties of an element. Therefore, he arranged the element on the basis of increasing atomic mass. Mendeleev periodic table contains 12 periods and 8 groups. After then Moseley, modern periodic law, Moseley said that atomic number is the fundamental property of an element. Therefore, elements should arrange on the basis of increasing atomic number. So these were the few history about which already I have described in the previous video. Now, first of all, what were the advantages of Mendeleev periodic table? So let's discuss about the Mendeleev's periodic table advantages. He left the vacant space for undiscovered elements like germanium. Mendeleev's periodic table helped to correct the atomic mass of some elements like beryllium. He predicted the properties of unknown elements. Disadvantages of Mendeleev periodic table: when inert gas were discovered, the arrangement of the increasing order of atomic mass become wrong. In some cases like argon should be placed after the potassium and cobalt after nickel, etc. Inert gas was missing from the periodic table. Alkali metals like lithium, sodium and potassium were placed with coinage metal like copper, silver and gold. No places for isotopes. There was no demarcation between the metals and non-metals. Lanthanide and actinides were not given proper position in the table. Atomic mass was considered the fundamental property of the element. So these were the advantages and disadvantages of Mendeleev periodic table. Modern periodic table. Modern periodic table is based on the modern periodic law, which states that the physical and chemical properties of the elements are the periodic functions of their atomic number. There are 7 periods and 8 groups in the periodic table. There are 4 blocks, that is S, P, D and F blocks. S block contains 2 groups, first A and second A, also called alkali metals and alkaline earth metals. P block contains 6 periods, that is 3rd A to 8th A, while D blocks are transition elements from 3rd B to 2nd B. F block is lanthanide and actinides present in the bottom of the periodic table. S and P block elements are called normal elements. D block are outer transition, while F block are inner transition elements. Periods: first period contain 2 elements and it is the shortest period. Second and third period contain 8 elements each and called short periods. Fourth and fifth period contain 18 elements each and are called long periods. Out of 18 elements, 8 are normal and 18 are transition. Sixth is the longest period, contain 32 elements. Out of 32 elements, 8 are normal, 10 are outer transition and 14 are inner transition elements. Inner transition of this period is called lanthanide series. Sixth period is the only period contains all the blocks. Seventh period is incomplete, which contain 2 normal and 14 inner transition elements. Other are transition. Its inner transition elements are called actinides. Elements after atomic number 92, uranium are transuranium, they are artificial elements. F block elements are called rare earth elements. There are 8 groups which are further subdivided into subgroup A and subgroup B. Subgroup A are called normal elements, typical elements or representative elements. Subgroup B are called transition elements. Group A and 2A are called alkali and alkaline earth metals respectively. Group 6A, 7A and 8A are called chalcogen, halogen and noble gases respectively. Group 1st B are called coinage metals, that is copper, silver and gold. Group 8B contains 3 columns. Group 1st A and 2nd A elements are entirely metals. Group 7th A elements are entirely non-metals. Positions of hydrogen in the periodic table: similarities with alkali metals, same electronic configuration NS1, same oxidation state. Both hydrogen and alkali metals are reducing agent. Both are deposit at cathode during electrolysis. Both form cations. Differences: hydrogen is a gas while all the first group elements are solids. Hydrogen needs 1 electron to complete its valence shell. Hydrogen form diatomic molecule while alkali metals cannot. Oxides of alkali metals are strongly basic while H2O is neutral. Similarities with halogen. Both are nonmetals, physical state, diatomic molecules formations. Both need one electron to complete its valence shell. Both form hydride and halides. They combine with alkali metals to form alkali metal and hydride and halide. Differences: hydrogen containing one electron in its valence shell. Halogen deposit at anode during electrolysis. Halide ions are stable in aqueous solution while hydride ion is unstable in water. Hydrogen can form cation while halogen cannot. Hydrogen is colorless and odorless while halogens are colored and possesses some odor. Halogens are oxidizing agent and hydrogen is normally reducing agent. Similarities with carbon. Both are nonmetals. They have half-filled valence shell. Both are reducing agent. Electrochemical properties are closer to each other. Both are present in organic compounds. Periodicity of properties. Periodic properties. The repetitions of the properties after certain interval is called periodicity of properties. These properties are called periodic properties. Different periodic properties are atomic size or atomic radius. What is atomic size or atomic radius? The average distance between the nucleus and the valence shell is called atomic radius, or half of the distance between the center of the two adjacent atoms, any element. Factors: nuclear charge, number of shells, and shielding effect. Atomic size increases from top of the bottom along the groups and decreases from left to right along the period. Unit used for atomic size is angstrom, nanometer, or picometer. Ionic radius, distance between the center of an ion and the outer boundary of the electron's cloud. Ionic size is the size of cation or anion. The size of cation is smaller than the neutral atom, while the size of anion is greater than its neutral atom. Ionic size also depends on number of cells and nuclear charge. Ionization energy, the amount of energy required to remove the loosely bound electron from the outermost cell of gaseous atom is called ionization energy. Factors: atomic size, nuclear charge, shielding effect, and electronic configuration. Decrease from top to bottom and increase from left to right. Its unit is kilojoule per mole or kilocalorie per mole. Ionization energy of group second A is greater than third A, and of fifth A is greater than sixth A due to the stable electronic configurations of group second A and fifth A. Lower of ionization energy, higher the metallic properties of electropositivity. Lower the ionization energy, higher the reactivity of the metals. Electroaffinity, the energy released or absorbed when an electron is added to the gaseous atom of an element. Factors: atomic size, nuclear charge, and shielding effect. Trends: decreases from top to bottom and increases from left to right in the periodic table. Non-metal have high electron affinity. High electron affinity means non-reactive non-metal. Electronegativity, the tendency of an atom to attract the shared pair of electrons towards in a molecule is called electronegativity. Remember this define. The tendency of an atom to attract the shared pair of electrons towards in a molecule is called electronegativity. What are the factors? Atomic size, nuclear charge, and the number of electrons in a valence shell. Increase from left to right and decreases from top to bottom. Fluorine is the highest electronegativity element and cesium is the lowest in whole periodic table. Hydration energy, the heat absorbed or evolved when 1 mole of gaseous ion is dissolved in water to give an infinite dilution. Factors: hydration energy depends on ionic size and nuclear charge. Lower the size and greater the nuclear charge, higher the hydration tendency. Therefore, positive ions have greater hydration tendency than negative ions. Aluminium 3+ has greater hydration tendency than magnesium 2+, which has greater than sodium plus. Hydration energy decreases from top to bottom and increases from left to right up to third A. Oxidation states, the apparent charge positive or negative present on an atom's compound is called oxidation number. Oxidation number is directly related to the group number to which the element belongs. The oxidation number of the group first A is +1 and that of second A is +2. Oxidation number of P block is the number of electrons in the valence shell or the efficiency of electrons in the valence shell. The variable oxidation state of P block is also due to inert pair effect. The variable oxidation state of D block element is due to involvement of unpaired electron of D subcell. Zero group shows zero oxidation state. Oxidation state of element is free state is also zero. Melting and boiling point. melting and boiling point of the metal depends on the strength of metallic bond. Stronger metallic bond, higher will be the melting point. Metallic bond depends on the number of free electrons and nuclear charge, which increases from left to right up to the middle of the D block. Melting point of metals decreases down the group. Melting point and boiling point in metal increases from left to right up to the middle of transition metals. The melting point and boiling point of the nonmetals depend on the strength of the intermolecular forces of attractions. Nonmetals form molecules. Melting point and boiling point of nonmetal increases down the group because intermolecular forces in nonmetal increases down the group. Metallic character or electronegativity or electropositivity, metallic character, you know very well metals are electropositivity. So the tendency of losing electron of an element is called electropositivity or metallic character. The factor size of the metal, ionization energy, and the number of electrons in the valence shell. Greater the size, lower the ionization energy, and less number of electrons in the valence shell. Higher is the metallic character or electropositivity. Trends: metallic character increases from top to bottom and decreases from left to right in the periodic table. Cesium is the most reactive metal of the periodic table. Electrical conductance, the ability to conduct electricity. Electrical conductance is due to the presence of free electrons in a metal. The more metallic properties, greater will be the electrical conductivities. Electrical conductivities increases down the group while it decreases from left to right. Copper, silver, and gold are excellent conductor because of the similar electronic configuration of group first A due to the stability rule. Chemical reactivity, a metal. The reactivity of the metal depends on ionization energy. Lower the ionization energy, higher will be the reactivity metal. Therefore, the activity of the metal increases down the group and decreases from left to right. Alkali metals are most reactive metals. They react with water and atmospheric oxygen at room temperature. They form ionic bonds. Nonmetals. The reactivity of nonmetals depends on the electronegativity and electron affinity. Higher the electronegativity and electron affinity, active. Higher the electronegativity and electron affinity, reactive will be the nonmetals. Reactivity of nonmetal decreases from the group because of the decreasing the electronegativity and electron affinity. Fluorine is the most reactive nonmetal. Periodicity of chemical properties like halides. You can see here the binary compounds of halogens with the other elements are called halides. There are two types of halides, ionic halides and covalent halides. Ionic halides, when alkali and alkaline earth metal combine with halogen, form ionic halides, except beryllium, which form covalent halides like sodium chloride, potassium chloride, and calcium chloride. Beryllium chloride is covalent. They are crystalline solid, have high melting point and boiling point, have high lattice energy. Covalent halides, when weak metallic or non-metallic elements combine with halogen, it forms covalent halides like boron chloride or boron trichloride or carbon tetrachloride, phosphorus trichloride, sulfur dichloride, etc. The metallic property decreases from the left to right, therefore the ionic properties of halide decreases from left to right. The ionic character of halides increases from top to bottom. When an element can move or when an element can form more than one type of halides like strontium dichloride, strontium tetrachloride, or lead dichloride, lead tetrachloride, the halides of lower oxidation state are more ionic. Similarly, ionic character decreases in the order sodium fluoride is greater than sodium chloride, is greater than sodium bromide, is greater than sodium iodide. Aluminum trichloride, beryllium dichloride, selenium tetrachloride form polymetallic halides. They form a layer or chain. Fajans rule. This rule states that ionic character of a compound increases with increase in the size of cation, but decreases with the increase in the size of anion. Therefore, cesium fluoride will be the highly ionic because its cationic size is the largest and ion size is the smallest. Similarly, aluminum trifluoride is ionic, but aluminum trichloride is covalent. The binary compound of hydrogen with other elements are called hydrides. Hydrides are ionic hydrides. The hydrides of alkali and the bottom member of alkaline earth metal form ionic hydrides like sodium hydride, potassium hydride, calcium hydride. These hydrides are crystalline, solid, and are also called saline hydrides. They are good conductors in molten state. The hydrides of beryllium and magnesium represent the class of intermediate hydrides. Their properties are between ionic and covalent. Covalent hydrides, nonmetals, form covalent hydrides like boron trihydride, carbon tetrahydrogen, or methane, you can say ammonia, water, and hydrogen fluoride. These hydrides may exist in the solid, liquid, or gaseous state, depends on the intermolecular forces of attraction. Hydrides of the first member of groups 5th A, 6th A, and 7th A, like ammonia, water, and hydrogen fluoride, has high melting point and boiling point than others due to the hydrogen bonding. Stability of covalent Hydrides increases from left to right in a period and decreases from top to bottom in a group. Fluorine form the most stable hydride, and the least stable are those of thallium, lead and bismuth. The order of stability of hydrides on the second period is: hydrogen fluoride is greater than water, is greater than ammonia, is greater than methane. The order of hydrides of group 5th A is: ammonia is greater than phosphine, is greater than osmium hydride, etc. Melting point and boiling point of hydrides of group 4th A is: methane is less than silicon hydride, is less than germanium hydride, is less than tin hydride. Oxides, binary compounds of oxygen. When we move from left to right in a period, the ionic character of the oxide decreases and the acidic character increases. The order of ionic character of the oxides of second period is: sodium oxide is greater than magnesium oxide, is greater than aluminum oxide, is greater than silicon oxide, is greater than sulfur dioxide, is greater than chlorate. The order of acidic strength is opposite to them. The oxides of first A and second A group form ionic and basic except beryllium, which is covalent and amphoteric. The basic character of oxides and hydroxides of group 1st A and 2nd A increases down the group. Therefore, the order of strength of basic character is: cesium hydroxide is greater than rubidium hydroxide, is greater than potassium hydroxide, is greater than sodium hydroxide. Oxides of aluminum, gallium, tin, lead and bismuth are also amphoteric. Oxides of nonmetal are covalent and acidic. Highly reactive nonmetals are more acidic, will be its oxide. Therefore, the chlorate is most acidic. Alkali metal are the only group which can form normal oxides, peroxides and superoxides. Potassium oxides and rubidium oxides are the superoxides, while hydrogen peroxide and sodium peroxides are peroxides. Bottom of the elements of alkaline earth metals can form peroxides like beryllium oxide or peroxides. Group 4th A element can form suboxides like C3O2 and G3O2. So these were the trends of periodic table. I hope all of you have enjoyed. Thanks for watching the video. Thank you very much. If you have liked this video, then please subscribe the channel and share this video with your friends. Thank you very much.